questions did you want to see to go over on the short guide?
No, you can go to the bathroom.
Oh, here you go.
What did I get? Which one?
So we see a lot of 1s and 2s and 3s. So we'll do those 3. So number 1 can be checked in desmos, but you have to know your exponent rules in order to do this first. So we can actually divide the 2 and 3, but the exponents we have to subtract. So divide 2 and 6, and then subtract all your exponents. So negative 4, y to the 5th, z to the 6th. And then rearrange this so that your negative exponents become positive. So that would get moved to the denominator. And y and z would stay in your numerator. So y to the 5th, z to the 6th, over 3x to the 4th. So you can check this in desmos, but you can't do it in desmos.
So why is it why is it 3 not 1/3?
Because we divided. It was never 3. It was always 2 divided by 2 divided by 6 would be 1/3. It's not 6 divided by 6. So it was never 3. This is still 1/3. It's in the denominator, so it's still 1/3. The 1's just invisible. So let's say we typed in the original problem, capitalize your x's and y's. The z doesn't have to be. Add in all the sliders. I already did that. Change these values to, I would say, keep them positive. It just makes your life easier, but just make them different. And then put in your final answer, and the numbers should match. But this one cannot be a did in desmos, so you have to actually do this one. Number 2, write the equation number 1 as parallel to the given equation. You can do that one completely in desmos. So we're going to type in the ordered pair. Type in the equation that was already there. And then if I'm looking for the equation of a line, I know I need my y equals mx plus b. I'm going to add in all the sliders, change my m since it's parallel, it has to be the same, so 2. And then move my b slider until it goes through that point. So the equation would be y equals 2x plus 7. And that one you can say did it desmos.
So parallel, perpendicular, opposite reciprocal.
Yes. Get it. Alright, and then number 3 is one of your literal equations. You're literally solving this with a variable. So for x, we get rid of a by adding it to the other side, but not combining because they're not like terms. And then divide everything by 5. So x equals b plus a over 5, which would be c.
So if we did our work on the sharp side, can we still copy it on?
Other questions on those things? Make sure your name is on your shortcut answer sheet and pass those up. So starting with 15, you would have dragged these to the correct spot. So the first one was greater than or equal to. The second one was just greater than. 16, this on the app on the computer would have been a drop-down menu. Can't do that on the paper. So the first one would have been down. The second one steeper. So 17 was similar. The first one was 1/2. The second one was 2 more than. 18, you have to plot any of these 2 points. So you don't need all of them, you just need 2. But you shouldn't have a line because it just asks you to plot 2 points. Now, there will be some where it asks you to form a line, but what will happen is you'll plot 2 points and the line will magically appear between the 2 points. 19 goes back to domain and range, what we talked about last class. If you would put that function into desmos, you would see the range is everything greater than or equal to 3. 20 and 21 could also be done in desmos. Which one has exactly 1, 0? Look for which one crosses the x-axis only once. And that was your g of x and j of x functions. And then for 21, the functions that have an x-intercept of 3, again, look for which one does that. It would be the h of x and k of x functions. Okay. The ones that will be due next Tuesday are 22 through 28, the rest of the pattern. Are there any of the ones we just did that we want to go through by hand or in demos? By hand or in demos? We'll just do that in demos. So I'm going to just, I have all of them already in there, and I'm just going to show you what actions to do.
You were here in 2017. You ready for school? Then you can be here after.
So on 20, you're looking for which one has exactly 1, 0. I think that's what I said. So of these, this one does not. This one doesn't even touch it. This one does not. And these 2 are the only one that has 1 x-intercept. Other questions from the test map packet?
No.
We can start this very briefly, but no, we'll finish after. Look at the notes on your desk. This is the last thing we need to talk about for the new things. So function notation is going to be very similar to evaluating, but it looks different. Instead of an equation, we're going to write it, or you're going to see it in function notation. Where you see like a f of x instead of a y. They're really similar. Y equals is for equations. F of x is more for functions, input-output type thing. Where equations you solving those, graphing those sort of things. This is read as f of x. So anytime we evaluate these, we're gonna put the value in for x. So for for these examples, you have f of x equals x plus 7. I have f of 5. That means my x value is 5. So I'm going to put 5 in for all my x's.
So 5 plus 7.
Which would give us. You can write the final answer one of two ways, like this, or just f of x equals 12. One way is saying when x is 5, y is 12. The other is just saying y is 12. But either way, it doesn't matter. Okay. Before we do part B and C, did you have questions about part A? I already forgot it. Oh, no, I didn't. Really? So we're going to do the same thing for B and put -1 in for your x's. Like that. And figure out what your y value would be. Which is 6. Or you put f of x equals 6.
Can you just write down like the answer, or do you have to write down like
So
the
if
steps?
if you were testing this, you would have to write down you putting the x value in and the answer. But for now, you could just write the answer as long as you know who you got. And then do the same thing for C. It is 4. I'm going to show you how you can do this in the calculator / desmos. So you're always welcome to do it by hand. If you wanted to do this in your calculator, you would go into y equals, type in x plus 7. And you can do this in Desmos too. I'll show that in a second. Go into the table. How do you do that again? To go into the table. Second graph. Okay. And then for the y value, for the x values given, just look for those y values. So at 5. At 5, y is 12. At -1, y is 6. At -3, y is 4. So you can use the table or do it by hand. Same thing in Desmos.
Are we gonna have this calculator so we can get actual x?
You're gonna have Desmos. Well, that means you will have Desmos and that's what we So you can do this a couple different ways. You could just type in the last part. You could type in y equals. You could type in f of x. Either way, it's going to give you a line. You could find the points along the line, or you can make this into a table. Some of the points may be there already, like -1. The other ones you would just add to the table. Questions there? Look at numbers 2 through 6. Which of those do you want to see? Do go over and have questions about 6, 3, 6, 3. Alright, so I'm still going to set each one up, but you can use Desmos the calculator, do it by hand, and start to find these values. H of -3 would be -3. h of 0, and h of none. 5. Questions on any of those three? That's just the function that was given. That was just the function that was given. Okay. This is the function. You're just putting this in for x.
Oh, okay.
It's just evaluating it in a different format. Other questions on number 3? Do the same thing for 6. You do it by hand in Desmos in the calculator. I'm just going to set each one up again. Did we all get negative 31 for the first one? For f of negative 1, that's what we all got. And for f of 5.
I got 1.
Yes. Do we have questions about any of those?
Wait, is B 4 or what?
Let's see, it should be 1, negative 1, minus 6. It's negative 7 minus 4. It's a negative 11. Other 4. Yep. So either put that in your calculator into Desmos or do it by hand. I'm just going to set it up to show you what it looks like. What would f of negative 4 be? F of negative 1, 2. And then f of 7. Questions on any of those? Look at 7 through 10 on the next page. Do we have questions on any of those? So I'm going to set these up. The process is the same. Yes, it's in alpha window. all of these examples, because everything falls inside the absolute value, you're going to get positive answers for everything. So if you get a negative answer, double check your work. In case you missed what I said, in alpha window is how you find that absolute value is ADS. What would G of 4 be? G of negative 7. So this would be 4 minus 16. So that would be negative 12. Which would make it positive. Or if you just put it all together, it would be positive 12. And G of negative 3. What's the value? Your choice. Questions on any of those? Look at number 11. In this problem, anthropologists use the length of certain bones of a human skeleton to estimate the height of the living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, the function h of x equals 61.41 plus 2.32x can be used. We have to find h of 46. So this part is just the same. We're putting 46 into x. What would that be? When x is 46.
Scroll along.
You could also use, if you're in the table, the table set.
174.13.
I was going to be 168.13.
Oh.
If you're scrolling in the table, you could use table set. If you go into the second window on that, you can change this to start at 46. And then when you go into the table, it'll already be there. In Desmos, you would just type in 46 and then you have your answer. So then, from part B, it's asking what does this. Oh, go ahead.
She was 168.3.
She was 168.
13.
Okay, that part, yes.
I forgot what that is in industry, please. General word, I guess.
What about the 46? What does that represent?
It is the length. That's the length. The length of the
Units, I don't know what it actually is. I also wrote that backwards. So that's just being able to take pieces, still evaluate, but also read it and understand the context of it. Questions on 11 before we do 12. So 12 is very much the same thing, but now it's on a graph. So it's saying when x is negative 4, what is the y value? is -4, what is your y value there? What was your y value? 2. And you could just leave it like that, or you could put f of x equals 2 plus you. Bless you, my goodness. Okay. What about f of 0?
0.
F of 2?
Negative.
-2. And f of 5? -1. Questions about any of those? This is just knowing what you're given, being able to find the other thing from the graph. On to the next page. This last part is very similar to what we started off doing, but now instead of saying f of some number, they give you a list of domain values, and you have to find the range values by either putting each one in and doing it algebraically or using your tables/desmos. I'll show both. So if I were doing this algebraically, I would just put each one in. And then simplify each one and figure out what each one was. So f of 4 would give us -1. And then if we do the same thing for 6, and then for 8. Sorry, not like that. But then your final answer needs to look like the domain. So we're looking for the range. And we're going to list those 3 values least to greatest. So we wouldn't leave them as we have them. We would actually put it in curly brackets. But the same way we did this in the table in Desmos would be the same way you do this. Do we have any questions on that? Are there any others on this page you want to see you go over and have questions about? So then we're going to switch gears. Go on to the next page. It's going to look very similar to the very first one. We're going to skip that part. Now, we're given f of x equals some number. So now we're given y, and we have to go back and find x. So again, I'm going to show you how to do this algebraically in the calculator in Desmos. So here, if I have f of x equals -5, this is my y value. If you want, you could rewrite this into y equals. So it just makes your life easier. And then for each problem, each part, you're going to substitute the y value. And you're going to solve for x. How would I do that in this case? Alright, 7. So that x equals -12. So you just leave it like that, or if you want to rewrite it as f of -12 equals -5, you could also do that. But the point is, we're looking for the x. We were given the x and had to find y, but now it's switched. So we're going to do the same thing for the others. really set up the same equation, but just change the y value. And you're going to do the same thing each time, subtract 7. So in this case, x would equal -7. And then if we solve the last one, x would equal 3. So in each of these, you are solving for x now instead of y. I'm going to show that in the calculator and then in decimals. So because we're now looking for the y values, you have to look at your y values and find those 3. So I see x being 10, I'm sorry, y being 10 right here. So I know that's going to be 3. When x is 0, I'll have to go back up. And that would be -7, and then for -5, I'd have to go back up again. So it's basically just backwards, but now you're looking at the y's first and then the x's. Sorry, did you grab some water? Yeah. In Desmos, it becomes like a guessing game. So I don't have any of the values I need right now, but I see this is really close, so I would guess that 3 would make this 10. And if that was wrong, I would just change the number. But I now have to go backwards to 0. So if we didn't already know, I would just start putting in numbers. So I know at -2 it goes to 5, so maybe at like -4. Close, but not really. And then I just keep going backwards. Oh, it was the other way. And I would just keep changing that until I get the y value I want. And then same thing for -5. So I know this gave me 0, so I'm going to go like -15. Okay, that was too far, and I just changed it. Until you get the right answer. So when finding your x values and your given y values, it becomes a guessing game on decimals. You can't put in y values, which is why you have to do that. Questions on any of those? How to put it in the calculator, Desmos, or algebraically? What other questions, 2 through 6, do we want to see you go over, have questions about? 7, 5. I'm going to set each one up, and then you can either do this algebraically in Desmos or in a calculator. So the letter at the front may change from f of x to g of x or something else. It means the same thing. I'm going to rewrite this as y equals. And then for each piece, change the y value. You can either solve each one, put this in the calculator, and find each y value, or put it in Desmos and start finding each y value. If you're doing it algebraically, you would have subtracted 9 and then multiplied both sides by -2. That work would be the same for each one. And then for B, what would that be? What would your x value be? And then do the same thing for C. This one?
Yeah.
We're taking this and flipping it and multiplying both sides. So you could do that by hand, each one. You could put the original equation into Desmos or your calculator and find the specific y values and look for those x values. Either of those ways would be fine. Do we have any other questions on this page? I'm so sorry. Okay. Any other questions on this page?
You said you multiply the -2. You only do to the negative of that side.
Do it to both sides. Yes. Look at 7 on the next page. It's very similar to the graph with the x's, but now we're given y values. So you would have to find your x values when y is -2 now. So when y is -2, what is your x value? What would that x value be?
Negative.
The x value, not the y value. 2. What about f of x equals 4? Wait, -2. You're looking at the y value, and it is negative. No, the y value has to be crossed into the y. I thought the y value had to be crossed into the y. It's a y-intercept. No, it's for y-intercepts. So at C, you would have 2 values, and they may not be exactly on the line. Yes.
Will 0 always be 0 in this case?
In this problem, yes. Always no. And C will have 2 answers. If they're not exactly on the line, you would just make up decimals. Do we want C? C? Yes. So when y is 2, what are your x values? 0. Not 0. 0.5. It's more than 1.5, maybe more like, I'm sorry, more than, it's not 1.5. It's close to 1. It's then you have another one.
Is that on the one of 4?
And then the bottom is just kind of what we already did, but now you're given the range, just like we were given the domain. So you could, again, set each one up algebraically, or use the calculator, or use desmos. So I'll do one algebraically, where I put each y value in and solve for x. And if I were doing this algebraically, I would be doing what to solve for x?
Add 5.
I'll do that once. So then the x value of this one would be 2. The x value of the next one, 5. And then of the last one, 10. So you would write those together in curly brackets, least to greatest. Are there any others on this page you want to see do go over? For the remainder of class, you do have a delta math on this, which is the last delta math of the year that's due on Friday. Your domain and range delta math is also due on Friday. You guys have JLabs that are due next week, test nav that's due next week, A-ball practice, past delta math, math gap, SOL. You have plenty to be working on. So work on something, use this time collectively.